So, in the last lecture, we discussed how to measure the equivalent circuit parameters of a transformer by doing open circuit test and short circuit test. In open circuit test, we apply that rated voltage in the primary, secondary is kept open. We measure the power consumed by the coil, magnetizing coil, that means transformer coil, and voltage and this current. Then we find out the power factor of the transformer in the open circuit condition, that is the wattmeter reading, that is power by V into I. Then from this cosine phi, we find out the value of sine phi, very simple. And then we find out what is the magnetizing current of the transformer, that IM will be equal to I0 sine phi, where I0 is the no load current of the transformer and IC is the loss component of this no load current, and that will be I0 cosine phi. Once I know IM and IC, this RC will be equal to V by IC, because it is just a parallel circuit, and XM will be equal to V by IM. So, on the short circuit test, we find out these series elements of the equivalent circuit, and this Z value, that means the total value R plus Jx, the Z value is just voltage by current. Here we apply, by adjusting the voltage, rated current through this transformer. So, rated current, at the rated current, the Z is equal to V by I. Resistance we measure by measuring the power consumed in the short circuit condition. That power divided by the rated current square is the resistance, and your this leakage reactance is Z square minus R square. So, let us see how it is calculated by doing just taking the actual data of a transformer. Say there is a transformer of 5 kilowatt transformer. Say transformer of 5 kilowatt, 50 hertz, it is operating at 50 hertz. Its voltage is 500 volt by 250 volt. Please keep it in mind, when this on all transformer, these voltage ratios will be given. This first figure will show what is the primary voltage, second figure will show what is the secondary voltage. That means this is the load side voltage is 250 volt and supply side voltage is 500 volt. So, on this transformer, this open circuit test is done, we call OC test. Open circuit test is done, and it is found that when 250 volt was applied, current was found 1 ampere and wattmeter reading was 100 watt. That means power consumed during open circuit at the rated voltage is this. Then in short circuit test, we call SC test, short circuit test. Voltage applied was only 25 volt, current was 10 ampere, and power consumed was 150 watt. So, this is the data we got from the open circuit test and short circuit test. We are required to find out the circuit parameter, that means equivalent circuit parameter, refer to primary. We will have to find out the rated circuit parameter, this equivalent circuit parameters, that means the shunt values and series values refer to primary. So, what is primary? Primary is 500 volt side, secondary is 250 volt side. Now, in the open circuit test, you see the voltage applied was 250 volt. It has to be rated voltage. 250 volt rated means it was conducted on the secondary side, that means low voltage side. And current was found to 1 ampere and 100 watt. So, if I want to find out that what will be the current, but I will have to measure this resistance and all these things in the primary side, that means 500 volt side. If I do that, what will be the current in the 500 volt side? If the 250 volt side current is 100 ampere, then we know that voltage ratio, here this your ratio, voltage ratio is voltage ratio or current ratio, whatever you call, that is 500 volt by 250, that means 2 is the voltage ratio or turns ratio of the transformer. So, the current which is at 250 volt, secondary side 1 ampere. So, actual current in the 500 sides will be this 1 ampere divided by this turns ratio, that means 0.5 ampere. So, 250 volt side 1 ampere current when it is referred to the primary, when you convert it to the primary side, the current will be 0.5 ampere. So, now with this 0.5 ampere current, applied voltage now we will take 500 volt. So, what will be the power factor? Power factor will be W, here W is 100 watt, it will not change, this watt will not change whether you will do it experiment on the primary side or on the secondary side, watt will remain same. So, 100 watt divided by voltage into current, voltage is 500 volt and current is 0.5 ampere. So, it is coming 100 by 250. So, 100 by 250, it will be coming 0.4. So, cosine phi is becoming 0.4. So, your sine phi will be 1 minus 0.4 square, that means root over 0.84. So, that is equal to around 0.92. So, sine phi is, cosine phi is 0.4, sine phi is 0.92, my current is 0.5 ampere. So, what is the value of IM? IM is I0 sine phi. IM is I0 sine phi. I0 sine phi. So, what is I0? I0 here is 0.5 into sine phi into 0.92. So, it is becoming 0.46. So, it will be 0.46 ampere will be IM, that is magnetizing current, and loss component of the current will be 0.5 into 0.4, that means 0.20 ampere. So, this is IM and IC. So, if I know IM and IC, I can now very well find out what is the value of R and X. So, what will be the value of magnetization, that means XM, magnetizing reactance, that will be the applied voltage is 500 divided by current is 0.46. So, this IM is 0.46. So, it is coming 500 1087, that means it is coming 1087 ohm, that means this is the reactance value of this XM. What will be the value of RC? RC will be 500 divided by IC, IC is 0.2. So, it is becoming now 2500 ohm. So, this will be the value of the RC value for this transformer. So, from the open circuit test data, we can find out XM and RC. XM is 1087, it is 1087 ohm, and RC is 2500 ohm. Now, from the short circuit test, we will find out the series elements of the transformer. So, what is the short circuit data? SC data is 25 volt, 10 ampere, 150 volt. 25 volt is coming around 5% of the whole thing. So, this has been already done on the high voltage side, that means on the primary side. So, from here I can find out what is the value of the impedance. Voltage by current is the impedance. That means voltage is 25 divided by current, that is 2.5 ohm is the impedance of the circuit. What is the value of resistance? We know W is equal to I square R. So, R is W by, what is W? 150 watt. What is I? I is 10 ampere, so 10 square. That means it is 100, so it is 1.5 ohm. So, 1.5 ohm will be the resistance. So, what will be the value of X? Value of X will be 2.5, that means Z square minus 1.5 square. That means it is coming 625. 6.25 minus 2.25, that means 2. So, it will be 2 ohm. So, X will be 2 ohm and W, this resistance will be 1.5. So, it will be 1.5 ohm and X will be 2 ohm. Just observe the value. The magnetizing reactance is so high, 1087 ohm, whereas the series leakage reactance is only 2 ohm. This loss component of resistance is 2500 ohm. Here resistance of the winding is actually 1.5 ohm. So, when the under loaded conditions, this resistance is very small, so most of the current passes through it. That is why we are telling that because of this high value of magnetizing reactance and the resistance, the current I, magnetizing current, is always very, very small. But for calculation of losses, especially coal losses, we will have to always account for this magnetizing current. So, the next lecture rather, we will be discussing about the other form of equivalent circuit.